Welcome back, guys. In the last video, we talked about the top view and the bottom view of a binary tree, right? So in this video, we'll talk about the left and the right view of a binary tree. So firstly, what is the left view and what is the right view? Now try to visualize it. If this was a 3D structure and you take a look of this picture from the left side, you'll only see the outermost nodes, right? Because the other nodes, they'll be overlapped by them, they'll be hidden by them, okay? So let's say if I try to, draw horizontal line based on their depths, right? So let's see what happens. This is unique at its depth, right? Since it's the root node, it is the only node at that particular depth. And what about this? At this depth, we have two nodes, right? And at the depth, when the depth is three, we see we are going downwards. So at the depth three, we have three nodes, and at the last depth, we have again three nodes. Okay. So now, if you take a look from the left side, you'll only see the topmost nodes. Topmost in the sense that the outermost node, right? So you'll only see this node, okay, and here you'll only see this node because 3 is 3 is overlapping 10. 10 is hidden beneath 3. You'll only see the 3 node, okay, and after that you'll see 1, and similarly you'll see 4. So if I talk about this particular binary tree, then the left view should be 8, 3, 1, and 4. Okay, now what about the right view? If I talk about the right view, again the same thing, same picture, same diagram, same horizontal lines. Just try to visualize it from the right side. You're looking from the right side, then you'll see 8, you'll see 10, you'll see 14, and you'll see 13, right? 7 and 4 will be hidden by 13, 6 and 1 will be hidden by 4. Okay, so today, how are we going to solve this question? How are we going to print the left and the right view? So if you remember correctly, then in the when we were solving that top and the bottom view, we talked about a thing known as the horizontal distance, right? So here we'll talk about the same concept but in a different language. We'll talk about the vertical distance. Okay, so what we did was, suppose, uh, let me just revise what we did in the last video. So for every horizontal node, if it was the first occurrence, we simply printed that, right? So we'll do the same thing in the right view also. Sorry, in the left and the right view also. I'll actually calculate the vertical distance, not exactly calculate. In the last view, for the top and the bottom, we actually change the structure of the nodes a bit. But here we don't need to do that, because what we'll do is we'll simply do a DFS. We'll simply do a DFS, and we'll just keep on marking the nodes. We'll just keep on marking the depth of these nodes. And if it's the first occurrence of that particular depth, we'll print it. What I mean by that is very simple. Let me just give me a moment, okay? So I hope you remember what the depth first search is, right? We basically go to the child first and then we go to the siblings. Okay. So firstly, let's start with 8. I go to its left child, right? And then I go to 3. Okay. And then I go to its again left child, then I print 1. Sorry, then I go to 1. Okay. So, and after that, I come back and I go to 6. I'm just telling you about the DFS, what a DFS is, right? And in this way, we'll just traverse all around. Now, what we'll do is simply, firstly I'll just mark its let's say its depth as 0. Okay, I'll just mark its depth as 0. Now we'll move forward, and I do a DFS. I go to its left side. Since I'm going to its left side, what I do is I simply increase its I take the depth of its parent node, that was 0, and I increment it by 1. Simple. So its parent node value was what, 0, so I incremented by 1 and I'll get 1. Okay, so it means that it is at the depth of 1. Done. Now again I'll do a DFS. I come to 1, I come to this node, okay, and I take what is the depth of this 1? Its parent node plus 1, so it will be 2. Now while I'm marking their while I'm marking their what while I'm marking their 0 1 to these depths, what I do is, if this is the first occurrence of that particular depth, which is exactly correct, right? This is the first occurrence of that particular depth. So I print 0, I print 1, I print 2. Okay, and after that what will happen is I'll go to 6, I'll go to this node, right? And what is the depth of this? Its depth is, let's say, 2, right? But this is not the first occurrence of the depth 2, right? So I won't print it. Then I go to the left side and I see that, okay, what is the depth of 4? What is the depth of the node 4? Its depth is 3, and this is the first occurrence of the depth 3. This is the first time we have talked about the depth 3, right? So we print 4, and after that, I can just traverse through the whole graph, but that will be the we have already seen traverse through all the maximum depths, that would be 3, and we have already founded our answer. So our answer shall be what, 8 and 3 and 1 and 4, right? So this was our answer, 8, 3, 1 and 4. So this will be the pattern that I'll be following. Okay, pretty clear, right? Now if I talk about the same thing, but how do I print the right view? For right view, what I'll do is it's very simple. When I was traversing, what I did was I first viewed the left child and then I viewed the right child, right? That is a DFS line. We first go to left child and then I go to right child. But what if I first go to right child and then I go to the left child? If I do this thing, if I just change those two lines, I hope you remember that we called those two functions. Firstly we went to the left child and then we go to the right child. But what if I first go to the right child and then I go to the left child? Well, that will solve everything. That will actually solve everything. You will firstly print the right view, because let me just actually I'll just give you another example. So this will be the first node without a doubt. Root node will always be the first node. Okay, so when I come here, 8, okay, this will be the first node. 0, I'll print it. This is the first occurrence of the depth 0, right? So after that I move to the right side since I'm first calling the function, right? Okay, then I go to 10. I go to 10 and this is its depth is 1, and again this is the first occurrence of depth 1, so I print it. Great. And then I go to 14. I go to 14, right? And this is again the first occurrence of depth 2. Its depth is 2, right? Then I print 14, and then I go to 13, right? In DFS, we first go to the child, then we go to the sibling. Okay, and by sibling I mean those nodes that are on the same level. So after that, 2 and 13. Okay, so what is the depth of 13? This is 3, and this is the first time we have talked about the depth 3. So great. 0, 1, 2, 3, these are all the first occurrences, and we have printed 8, 10, 14, 2. Now you can traverse through the whole graph. In fact, you will traverse through the whole graph. But what is the point, right? You'll come here, you'll see that okay, its depth is 1, but we have already printed it. Its depth is 2, but we have already printed it. Its depth is 3, but we have already seen it. Nothing new, right? After that, we'll see about here. So its depth is again what, 3, printed it. So this way we can traverse throughout the whole graph, but it doesn't matter, right? Because what is the main problem of solving this question? Just keep check of the depth, and if that is the first occurrence of that particular depth, print it. Simple. How do you increase the depth? When you are calling the left or right function, just you have to pass a variable known as depth, right? Just increment the value of the depth by 1. Simple. Now let's move on to the coding part. All right, now let's start with the coding part. So before that, let's just take a look at the image on which we are working. So this is the tree on which we are working, and I know it looks a little bit weird because of that video we created on top and bottom view. But uh, if we try to think objectively, we will know that 5 and 17 are on the same level, or are on the same depth, because they are the child of the same node, right? So 5 and 17 are on the same depth, and 4, 7, 14, and 19 are on the same depth. Okay, so now let's start. But before that, I'll just simply call my function, and I'll just name him as left view, and what left view. Mm, I'll need to pass my root only, right? Because that is what I need to access. So let's start with creating of a function. So left view will actually not be the main part of the code. Left view is basically doing that initializing part. Think of it as a constructor, right? Because I need to do a recursive call, and that I'll do in some other function. So because I need to actually initialize a few values like my maximum depth that I've accessed till now, and what is my current depth and all that. But I can't do that here because I can only initialize one. I actually only need to initialize one. So what I'm doing is I'm simply initializing it in left view, and I'm calling another function for doing a recursive call because I need to do DFS, right? So left view, and what do I need? I need a max depth that will actually show me how much I have actually what is the maximum depth that I have covered till now. So max depth, and I'll create a list ANS answer in a list, because in this I'll store the roots that I've accessed that actually store my answers. If I want, I can just print it then and there, but what I'm doing is I'm actually trying to store it in somewhere. So if if there's some question that actually it actually needs to perform some operations on this left view, so for that purpose only I'm just trying to store it, so it's much better than that. Okay, you can use it actually for some other questions also. So after that, I'll create a function, let's say left call. This way the function that will do my recursive call. So root and 1, because 0 has already been accessed, so root 1. And after that, my max depth that I've accessed till now, my max depth, and my answer, right? So now let me make my function def left call, right? Here I'll actually take 4 parameters, that will be root, and my depth that I've accessed till now, my max depth, yeah, and my answer. Okay, so now I need to check the first line that I always check is if root, sorry, if root is None. I hope you know why I check it, because I'm trying to see that the memory that the memory that I'm trying to access, is it even allotted to me? Because if it is not, then you might have heard of error known as segmentation fault. This error occurs when you are trying to access a memory that has not been allocated to you, right? That is the error that I'm trying to avoid using this particular condition. Okay. After that, I'll check that the max depth that I've covered till now, is it smaller than the current depth? If it is smaller, then it only means one thing, and that is that it only means one thing, that this is the first occurrence of that particular depth. And if that is the case, then what I do is I simply store that root dot node in my answer, and I just change the value of my max depth, right? Because this is the new maximum depth that I have accessed till now. Okay, yeah, done with that. And now the only two lines are left: left call again and left call again here. Okay, so I'm a little bit lazy, so I'll just pass these values. Okay. So now what change do I need to do? Firstly, everything else will remain same. Firstly, it will become root dot left, since I'm going to the left child, and depth will increase by one since I'm going one step down. So depth will increase by one, and similar case for left call of this. However, it will become right, but depth plus one will remain same. Why? Because we are going one depth right. Sorry, one depth down for this right also, right? So now let's try to, after that I'll just print my answer, and I think that shall do the trick. So what should be my answer? Let's discuss this beforehand. 12, 5 and 4. Okay, because 17 will be hidden by 5, 14 and 19 and 7, sorry, 7, 14 and 19 will be hidden by 4. So my answer should be 12, 5 and 4. Now let's try to run this code. Okay, I am having an error. Node object has no attribute node. Answer would append root dot node. Okay, why did I do that? Sorry, root dot data. Yeah, uh, sorry for that. Yeah, 12, 5 and 4. So our code is working perfectly, right? Now, if I ask you, how do you print the right view? Okay, don't go and create a new function. Just actually rather swap two lines. Which two lines? These two lines, right? Done. This is the right of that same tree. Because what I'm doing is I'm first accessing the right child, and then I'm accessing the left child. And what should be the right view? So the right view should be 12, 17 and 19. Let's try to run our code and see if it's working or not. So yeah, 12, 17 and 19. This was the right view. Simple, right? So this is how you print a left view and a right view. And if you want, just change the name for the left view and right view, because otherwise it seems a little bit weird. So yeah, this was the left and the right view. We didn't make any change in the structure of the node. Rather, we uh, just carried an extra variable. So yeah, that's all. And this is how you print the left view and the right view. By the way, there are many methods to print a left and right view. If you have something else in your mind, and if you want to, you can just mention them in the comment section. And yeah, I'll learn from that also. Thank you for that. So yeah, we're done for today, and thank you.